everybody, so today we are starting with chapter 6, okay. And in this section we're going to learn about two more parent functions. Okay. Section 6.1, we're going to learn about the graphs of the sine function and the cosine function. Now, to do that, let me actually turn my paper. That would probably be more helpful for us. Okay. So let's recall the unit circle. And we're going to graph in the forward direction. Okay. So this is the point 0, 0. Now halfway, no it's not, I'm sorry. This is the point 1, 0, sorry. Okay. And this is the point 0, 1. So we're going to be graphing f of x is equal to the sine of x. Alright. Now, this is our angle pi over 2. Okay. Half of the angle pi over 2 is pi over 4. Okay. We also have our angles at pi over 6 and angles at pi over, let's see, so this is 1 pi over 6, 2 pi over 6, so this is 2 pi over 6 is pi over 3. Okay. And then let's put in some of our other angles. Let's see, we know over here that this is the point -1, 0, and this is the point 0, -1. So this is the angle pi, and this is the angle 3 pi over 2. Okay. And then finally, this is 0, and when we come back around, we're at 2 pi. Okay. So once I've gone all the way around to 2 pi, if I keep going around the circle, I'm going back over the same exact pattern. So let's see if we can figure out what will happen in one looping, because that will be the pattern. Okay. So I want to graph up until 2 pi. Okay. Now let's just mark, so I picked some distance on here, 2 pi, and to help us write more symmetrical graphs, the easiest way is to mark out your distance 2 pi and then make a mark halfway in between that. Well, half of 2 pi is simply pi, and then we'll take half of that, which is pi over 2, and then we'll need this mark over here, but we can count it out. Pi over 2, 2 pi's over 2, 3 pi's over 2. So when I start at the angle of 0, sine is 0. Here, this is the point, the long triangle, square roots of 3 over 2, 1/2. Here, the sine has increased to 1/2. When I get to here, this is square roots of 2 over 2, square roots of 2 over 2. So as I get to the angle pi over 4, the sine has increased to root 2 over 2. As we travel along here, this is 1/2, the short side of the triangle, and then the long side, to square roots of 3 over 2. So here, the sine is square roots of 3 over 2, until finally we get to 1, where the sine is 1. Now that is the maximum value that sine will go to. So the maximum value I'm going to put on here is 1. Then the sine will begin to decrease through square roots of 3 over 2, through root 2 over 2 to 1/2, until finally here it's at 0. Then the angles, as we move through the angles, the sign will become more and more negative. Okay, so let's see where are we at. Let's put some thoughts in here. So let's count out the pi's over 4. We know these are going to be the halfway in betweens. Okay, 1 pi over 4, 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, which is just pi, 5 pi's over 4, 6 pi's over 4, which is 3 square roots of 3 pi over 2. So this is 6. So this is 7 pi's over 4. Okay. And we know the values here. Okay. So if this is, they both have the square roots of 2 over 2. We just have to adjust for the quadrant that we are in. Okay. In the third quadrant, both will be negative. And over here will be positive in the x, but negative in the y, okay, because of our quadrants. Okay. Now we can put in the thirds. Okay. Here, here, here. Okay. Now let's count out what they are. 1 pi over 6, 2 pi over 6. This is 3 pi's over 6. This is 4 pi over 6, which reduces to 2 pi over 3. 4 pi's over 6. This is 5 pi's over 6. 6 pi's over 6. This is 7 pi's over 6. 8 pi's over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And then finally 11 pi over 6. So it's going to be a little tight here, but the coordinates here then are negative 1/2, and then positive square roots of 3 over 2. So these two are symmetric. Okay. And then this point over here is the same. We're just going to go negative square roots of 3 over 2 and positive 1/2. Okay. Now these two are the same, but I have to go in the negative direction for both, because I'm in the third quadrant. And so this one will be the same as this one, except I have a positive x and a negative y. Okay. And then here, we'll go the short side, so it's coming down the same as this. So I have the negative x and the negative y. And this point and this point are the same, except I have the negative y. So this is the positive 1/2, negative square roots of 3 over 2. Okay. So there we've just redone our unit circle. We need to do that until we can do it by heart. Okay. So the lowest value that the sign will ever take on is this negative 1. Okay, so I'll put that down here at negative 1. Okay, so now let's take the easy points for us to look at and graph. So at 0, the sign is 0. At pi over 2, the sign is 1. So this is the point pi over 2, comma 1. Okay. At pi, we're back to 0. At 3 pi's over 2, we've decreased to negative 1. So this is the point 3 pi over 2, comma negative 1. And then as we continue around at 2 pi, the sign is back to 0. Okay. So those are the main points that we have. Now let's see what's happening in our first quadrant. Well, as I move from pi over 6, which is in here, to pi over 4, to pi over 3, these values of sign are increasing until they get to 1. Okay? So they are increasing until they get to 1 through here. Now, at pi over 2, we start descending. we go back, we start at 1, then we go to square roots of 3 over 2, then 2 roots of 2, then 1/2, until finally we're at the point where the sign is 0. So if we were to mark this as we move forward, from pi over 2 to pi, the sign decreases until it's back at 0. Now, from pi to 3 pi's over 2, we have to look. It starts at 0, then here we're at negative 1/2. As we come down to pi over 4, we're at, this should be negative root 2 over 2. At this point, we're at negative root 3 over 2 for the sign, until we finally get to negative 1. So what's happening to the values of sine? Well, the values of sine are becoming more and more negative. So the way we could represent that like this is from pi to 3 pi over 2, the values are becoming more and more negative until negative 1. Now let's consider what happens in the last quadrant, our last part of the circle. At 3 pi over 2, it starts at negative 1, then it goes to, this is negative square roots of 3 over 2, then it becomes less negative at negative root 2 over 2, less negative at negative 1/2, until finally we're back at 0. So in this way, the values are becoming less and less negative. And really, if I'm going to write, let's see, f of x is equal to sine, so we would write this as sine of x. Sorry, just to correct that. Okay, now if we start again, if we go from 2 pi, now over, if we were to extend this, okay, from 2 pi to 4 pi, that is, if we went another loop around the circle, the same exact thing would happen from 2 pi to 4 pi. Okay. So this is one cycle of the sine. One cycle of the sine, anytime we have one cycle, is known as the period. Okay. So one cycle will happen in one period, and one period in this case is 2 pi. Because if we started again, we'd go from 2 pi to 4 pi. The same exact shape would result. The period there for the shape, how long it takes, is 2 pi. We notice that there's a bound on this height, and the height from here to here, this is its tallest. This is known as its amplitude of the wave. Okay. It's a wave because it'll keep going. And notice if we just did it backwards, we'd just be going more and more negative, then less and less negative, then more and more positive, then less and less positive. It would be the opposite of this. So this is y is equal to the sine of x. Alright, now let's try and do some solving, okay, just some graphical solving. So for example, let's solve where f of x is equal to 0. Okay. Well, what is our f of x? Our f of x is the sine of x, so we're really solving where does the sine of x equal 0. Remember, we could solve this graphically. Okay, so we've graphed the sine of x. On the right-hand side, we want to know where y equals 0. We can draw that in. This is the line where y equals 0. Okay. And if we were to look for any intersection points, that would be the answer. Okay. So we see an intersection point here, here, and here. Now notice, I've only solved this because this graph goes on infinitely in both directions. I've only solved this on 0 to 2 pi. Okay. And 0 and 2 pi have the same, are coterminal. Okay. So when I make a notation like this, from 0 to 2 pi, and I put the parentheses around it, What I'm saying is that if you have multiple answers that are the same, include the 0 answer, but not the 2 pi answer. So in this case, we would not worry, because 2 pi is not included, we would not worry about this angle. Instead, we would worry about these two solutions. And for that, we could see on 0 to 2 pi that we get the angle 0 and the angle pi. Okay. Let's do the same thing. Let's solve where the sine of x is equal to 1 on 0 to 2 pi. Okay. 2 pi not included. Okay. So if we do that, here's the line y equals 1. Okay. We have only one intersection point. That is here. That angle that corresponds to it is pi over 2. So we only have one answer on 0 to 2 pi. There's, of course, an infinite amount, but on this restricted interval, it's just x is equal to pi over 2. Okay, so that is the sine of x. Now we have, let's do f of x is equal to the cosine. Okay. So that's the cosine, generally say of x. Okay. All right. So all right, let's do our unit circle again so we can see this happen. So we need to do this multiple times so we're good at it. Okay, here is the point 1, 0. Here's the point 0, 1. Here's the point negative 1, 0. And here's the point 0, negative 1. Okay? And then we'll fill in those angles. So this is 0, and this is pi over 2. This is pi. This is 3 pi's over 2. Okay? And if we come back around, this will be 2 pi. Now let's take half of those angles. So half of pi over 2 is pi over 4. Right? And then we'll just start counting. 1 pi over 4, 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, which is just pi, 5 pi's over 4, 6 pi's over 4, which is 3 pi over 2, this is 7 pi's over 4. Okay, so that takes care of the halves. Right, now we have the thirds. Okay, so come here. Okay. 1/3 times pi over 2 is pi over 6, and now we'll count. 1 pi over 6, 2 pi over 6, which reduces to pi over 3. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. Let's see, that was 4, so this is 5 pi's over 6. 6 pi's over 6. 7 pi's over 6. 8 pi's over 6, which reduces to 4 pi over 3. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 3. And finally 11 pi over 6. Okay, then let's fill in the coordinates. Okay, so the long side of the triangle, square roots of 3 over 2, and up the short side, which is 1/2. Okay. So that will be the same over here as well. This is now negative in the x direction and positive in the y. Okay. That corresponds to this point where they're both negative, which corresponds to this point where the x is positive, I should say 3, and the y is negative. Now for the long side of for this one, we'd do the short side of the triangle first, which is 1/2, and then we'd have to go up square roots of 3, which will correspond to this point, except I'll need to be negative in the x direction, still positive in the y, and then it will come down to these two, and this one, it's negative in the x and negative in the y, and this one we're positive in the x and negative in the y. Okay. And then we just have our quarters. So this is where they're both equal, square roots of 2/2. On this side, we're negative in the x and positive in the y. And they come down to these points. Third quadrant, everything's negative. And in the fourth, the x is positive, and the y is negative. Okay, so let's just make sure I have everything positive, 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 negative, 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 both negs. Okay, good. All right. Now at this point in time, what we're concerned about is our cosine values, which are the x. Now, when we do this, again, once we go around the circle once, we will have completed the cycle. Okay, so let's pick some amount, we'll say from here to here, and that will represent walking all the way around the circle. Okay. Then we'll pick half of that for pi, and then half again for pi over 2, and we can count out to get to this one, 1 pi over 2, 2 pi over 2, 3 pi's over 2. Okay. And let's see what's happening at these points. Okay. When x is 0, when the angle is 0, okay, our x value here is 1. By the time we get to pi over 2, the cosine value is 0. When we get to pi, the cosine value is negative 1. Okay, so we'll put that down here, negative 1. Okay. So this is pi comma negative 1. Okay. This is pi over 2 comma 0. This is 0 comma 1. Now, at 3 pi's over 2, we're back at 0. This is 3 pi over 2. And by the time we get to 2 pi, the cosine there is 1. So if the angle 2 pi, then the cosine is 1. So let's see what's happening as we go from 0 to 2 pi. Okay. Well, here we have a cosine of square roots of 3 over 2. By the time we get to pi over 4, we have a cosine value of square roots of 2 over 2. At pi over 3, we're at 1/2. And by the time we get to pi over 2, we're back at 0. So what's happening is as we increase through the angles, the cosine is decreasing to 0. Now, from pi over 2 to pi, okay, as we go forward at 2 pi over 3, we start at 0, and now we're at negative 1/2. By the time we travel to 3 pi over 4, the cosine is negative square roots of 2 over 2. By the time we're at pi over 6, the cosine is even more negative at negative square roots of 3 over 2, until we get to pi, where we're at negative 1. Okay. So as we increase from pi over 2 to pi, the values of cosine are becoming more and more negative until they get to negative 1. As we go from pi to 3 pi over 2, we're working the opposite direction, and the values of cosine are becoming less and less negative until they get to 0. Then from here, we write 0 for the cosine. As we increase, the values of the cosine increase until they get to 1. And so that is one cycle of the cosine. If we would go again from 2 pi to 4 pi, the same exact shape would occur. Okay? So this is one cycle of the cosine. Its period is the same as the sine. It is 2 pi. And it has the same amplitude. The highest point that the graph, and the lowest point, okay, is 1. The amplitude is 1. Okay, so these, of course, go on in multiple directions. You'll need to be able to create these. Okay, now that we know what they are, we're going to have to transform them. So let's go back this way. Now, for example, let's say we had to graph y is equal to 3 times the sine of x. Now, let's say, okay, so how can we do this? We could do it by table of values. Okay, this will be the long way. We'll do it once. Let's see. So let's just graph it on 0 to 2 pi. Okay. So if x is 0, we get 3 times the sine of 0, which the sine of 0 is 0. Okay, so we get 3 times 0, which is just 0. So we have the point 0, comma 0. Now at pi over 2, we have 3 times the sine of pi over 2, which is 3 times, and the sine of pi over 2 is 1. So we get 3. Okay, so let's see, let's graph this on 0 to 2 pi. Okay. So again, I pick a distance for 2 pi, then half of that must be pi, then half of that is pi over 2, and then half of that, 1 pi over 2, 2 pi's over 2, 3 pi's over 2. Okay. So at pi over 2, I have a value of 3. Okay. So let's label this as 3, so this is pi over 2, comma 3. Now at pi, we get 3 times the sine of pi, which is 3 times 0. The sine of pi is 0, which is just 0. So at pi, we're back at 0. At 3 pi over 2, we get 3 times the sine of pi over 2, which is 3 times, well, the sine of 3 pi over 2 is negative 1, so we get negative 3. So I'll label this as negative 3 and put it down here. So this is the point 3 pi over 2, comma negative 3. And then since we're graphing one cycle, we'll include the endpoint here of 2 pi. So this is 3 times the sine of 2 pi, which is 3 times, well, the sine of 2 pi is just 0, which is 0. Okay. So notice we have the same pattern here. Up, mid, down, up. Okay. It's the same. Okay. All we've done with this 3 times the sine is notice that we've changed how high up the graph goes. Here we have an amplitude of 1. Everything else is going to stay the same though. Okay. So one cycle of this will look like so. And now we can say that the amplitude here has changed, and now the amplitude is just 3. So this provided a stretch, and it changed the amplitude. Okay, this being the 3 in front here. Okay, so that changes the amplitude. Now we can answer questions about this. Let's say, for example, we wanted to solve where f of x is equal to -3, and let's just be simple about this on 0 to 2 pi for right now. Well, what is f of x? F of x is 3 times the sine of x is equal to -3. Okay. And we can do this graphically. Here's 3 times the sine of x. Here's the line y equals -3. And we have one intersection point. And that intersection point is when x is equal to 3 pi over 2. So we can do this graphically. Okay, so we have one solution for that. Okay. Now this is a long way to do it by actually plotting points. I'm going to show you how to do it using translation. So this is why it's important that you'll get these, the sine and the cosine shapes down. Okay. So we can just move through the translations. Okay. So for example, if y is equal to -1/2 times the cosine of x, there's a couple things that's going to happen here. Okay. This 1/2 is going to change the amplitude. Remember we talked about, well, with translations you can stretch or shrink. Okay, so this is a shrinking. Okay, it'll change the amplitude. It's going to compress this. Right? But we also have this negative out here, and this is going to provide a flip. It's going to take a flip over the x-axis. Okay, it's going to force it to change. So if we do it in stages, okay, so let's just do y is equal to the cosine of x. Alright, I pick some distance, 2 pi, mark it out. Then I need half of that for pi, half of that for pi over 2, and then I can count to get this one. 1, 2, 3 pi's over 2. Okay. Now normally the cosine has an amplitude of 1 and -1. Okay. And the cosine starts at 1, it will end at 1, halfway in between it's at -1, and halfway in between those it hits 0. So this is y is equal to the cosine of x. Okay, one cycle of it. So if I want to do the change of amplitude, this would be 1/2, this would be 1/2, -1/2. Okay. Now it would start at 1/2, end at 1/2, and right in the middle would be down at -1/2, and it will still hit these 0 points, okay, because 0 times anything is 0, and now it would look like so. It would be compressed. So this is our change in amplitude. I should really be dashing these in, so our final result will be here. Okay, now I'm going to write our final result over here so we don't get confused. So when you're doing these on your homeworks and when you're turning things in, make sure it's clear which is the graph you're working with. Okay, so at 1/2 and -1/2, and again we'll go to 2 pi, pick a distance, half of that is pi, half of that's pi over 2, half that's 3 pi over 2. Okay. Now this flip, this negative is going to cause a flip, which is a rotation. So instead of starting at +1/2, I'm going to start at -1/2. So I'll also end at -1/2. And halfway in between, instead of being at -1/2, I'll be at positive. Now the in-between points are going to stay the same because -0 is still just 0. Okay. So in the end, this is one cycle of the cosine of negative 1/2 cosine of x. Okay. Now it's going to be super, super important that you label your axes, okay, because these graphs all look the same, and I will be, on your exam, I will be checking that, because without any labels, I don't know if you have it right or not. Okay, so sometimes it's just as easy to like label pi over 2, comma 0, and like here say pi, comma 1/2. Okay, it might be a little tight, but I'll be looking specifically at your x-axis labels and your y-axis labels. Okay. Let's do another one. Okay, so for example, if we have y is equal to 2 times the sine of x, now plus 3. What we have then is this is going to force us to go up 3, and this one's going to change the amplitude. Okay, so let's do 1. And we'll put it all together. Okay. So again, I'm going to pick some period, some length, 2 pi. Then this will be pi. Then half of that is pi over 2. And half of that's 3 pi over 2. We're going to graph the amplitude change first. So the amplitude will go from positive 2 to negative 2. Now the sine of x starts at 0, ends at 0, and the middle is at 0. Halfway between this one it peaks, and halfway below that one it valleys. Okay. So this is y is equal to 2 times the sine of x. Okay, now let's label our points so we can see this happen. This is 0, 0. This is pi over 2, comma 2. This is pi, comma 0. This is 3 pi over 2, comma negative 2. And this is 2 pi, comma 0. Notice with the amplitude of 2, there's this nice line in between here. And this is what your book calls a midline. Okay, so from here to here is an amplitude. Now, and here, you could also look up here and see a midline too, right? It's like halfway in between. The amplitude here is 1/2. Okay. Now, all that's fine, but I have this translation where I add 3, so everything has to shift up 3 units. Okay, so let's mark this out. Pick some length for 2 pi. Half of that's pi. Half of that's pi over 2. And the other half's 3 pi over 2. Okay. Now I need this point to go up 3 units. So let's move up someplace, and we'll call that 0, 3. Now I know it has to middle and end there, so coming across with my midline, just for a little bit of scale and accuracy, okay, then the middle would have to be here, so this would be pi, 3 now, and the end would also have to be there at 2 pi, 3. I'm sorry, this should be 2 pi, 0. Okay. Now at pi over 2, I would do a peak, okay, and that peak is specifically the amplitude, 2 units. So I'm already at 2, I need to go up 2 more. So that would put me at the point pi over 2, 4. Okay. So that gives me an amplitude of, is that what would give me? I need to go up 3 units. So I was at 2. 2 plus 3 is 5. Sorry. Oh my goodness. Yes, this is right. 0 plus 3 plus 3 plus 3. 3, 3, and 3. And the amplitude is 2. Which add up to 5. Yes. Okay. Sorry, just double checking myself. Okay, so our amplitude now is 2. and we've gone up 3 units to 5. Okay. Now from here, I'm at -2, but I want to go up 3 units, so that puts me down here at -1. So this is the point 3 pi over 2 comma -1. Plus, no. Oh my goodness, you guys. -2 plus 3 is equal to +1. I'm sorry, you guys. Looks like this. Okay, so this is the point 3 pi over 2 comma +1. Okay, so now let's make sure I'm up. Okay, 0 plus 3, 0 plus 3, 0 plus 3. 2 plus 3 is 5. -2 plus 3 is +1. Whew! Okay, that wasn't supposed to be that difficult. Okay, and notice that our midline is the line y is equal to 3. Okay. Okay, so we have, what have we done here? Okay, we have 2 other changes to talk about. Okay, so for example, if we have y is equal to 3 times the cosine of 2x, what's going to happen here? We know this is going to change the amplitude. No problem about that. Okay. But what's this going to do? And it turns out this 2 here, by multiplying, this is going to change the period. Okay. That is, it's either going to shorten or elongate the cycle. How should I explain this? That is, I will be able to get twice as many angles in as I would have before. Okay. So what that means is that I've changed the period and it shrinks because I'm going to allow for twice as many in the same period. So let me show you what I mean by that. If you plot the points, we'll see this all happen. Okay. So some distance out here is 2 pi, some distance here is pi, some distance over here is pi over 2, and some distance here is 3 pi over 2. Okay. So if it was just 3 times the cosine of x, the amplitude would be 3, and of just x there would be 1, so I could get 1 cycle starting up top and coming down below in between here. But now I can get 2 of them in. Okay. So if I can get 2 of them in, the period is no longer 2 pi, it is simply pi. So let me show you. Okay. So if it changes, okay, so 2 in 2 pi. So if I can get 2 in 2 pi, that means I can get 1 in just pi. Okay. Now the cosine starts up top, ends up top, and halfway in between that, valleys, and halfway in between these two is 0. This is the shape of the cosine. Now we should label these. What is half of pi over 2? Well, that's pi over 4. Okay. And now we can count. Pi over 4, 2 pi's over 4. This would be 3 pi's over 4. This would be 4 pi's over 4. We may as well fill these in while we're at it. So this is 5 pi's over 4, 6 pi's over 4, 7 pi's over 4. And it works. I can get 2 in the same period. Okay, so now here from pi to 2 pi is just a period of pi. So if I start up top and end up top, then halfway in between that I'm here. That's a little bit high up there, isn't it? Coming across down below. Then halfway in between that, I'm at 0. And halfway in between that, I'm at 0. So I can fit an entire another cycle in. That is, I can get 2 in 2 pi, or 1 in just pi. Our amplitude here is 3. Okay, so that's kind of the basic changes. So let me give you the generic form of a sine wave. Okay. Let's just take a new piece of paper. So the general form of the sine wave. It also works for the cosine wave. Okay. Okay, these are cyclic functions, cyclic meaning a cycle, or periodic meaning you have a period. They're also known as oscillations because they go back and forth and back and forth. Okay, so the general form is y is equal to a times the sine of b times x minus c, and then we can always add some d. Or you could have the cosine version of it. Y is equal to a times the cosine of b times x minus c plus d. Okay. So what do all these variables mean? Well, we've seen from earlier that a changes the amplitude. And specifically, the amplitude is equal to the absolute value of A. Okay, we never have negative amplitudes. Now, B changes the period. And specifically, the period is equal to 2 pi divided by b. So these are the translations that are really unique to the oscillations. The rest we know. Anytime we take x and we subtract anything off it, that's going to provide, it's going to shift the graph left or right. And that moves us, in this case, C is called a phase shift. So that's a terminology, new terminology to this. And then anytime you add or subtract a function, D, a constant to a function, it's going to move it up or down. Alright, now this is going to take a little bit of work, but we can do it. Okay. So let's try and put all this together and do a more complicated one. Alright. Example. Let's say y is equal to 5 times the sine of 3x plus pi, and then we subtract 2. So we know a few things. Okay? If it's written in this form, then we know exactly what A, B, C, and D are doing. Okay? Notice that this is not written in the form. We have 3 times x, but there's also some constant being added here. So our x needs to have a coefficient of 1. So let's rewrite that. That is, we're going to have to factor out this 3. So y is equal to 5 times the sine, and then I will factor out the 3. And now we'll have a positive x here because I multiply the 3 through. But now, what do I have left here? Well, notice to get to just x, I divided this by 3, so I would get 1x here. I also need to divide this by 3. So it's that I'll add pi over 3, because that way when I multiply it through, 3 times pi over 3, right, this is just 3 over 1, these will cancel, it's just equal to pi. Okay. And then minus 2. Okay. So that's going to take a little practice. Remember, factoring out is just the same thing as dividing. Okay. So now we know A is equal to 5, B is equal to 3, C is equal to, and here's where we also have to be careful. Okay. These are written with negatives here. Okay. So C is equal to, now these are positive, so this needs to be negative pi over 3. Okay. And D is equal to negative 2. Alright, let's determine everything. Okay, so our amplitude, that's the absolute value of A, is equal to the absolute value of 5, which is just 5. Okay, we know that. Now B affects the period. Now the period is equal to 2 pi divided by B, which in this case is 2 pi divided by 3. Okay, so that's going to be one cycle. Right, that's going to take a little bit of work, but we can get it done. Okay. And now the rest of it I just like to think about. Okay, remember our acronym. This tells us that we have a negative phase shift, but I can also think about it this way. Remember when we're translating, when we have a plus, we're going left, and when we're right, we subtract. Okay, so to do that, I always use this acronym LARS. And so see, I am adding pi over 3, so I must be going to the left. Okay, so we're going left, negative pi over 3 units, and then this is going to drop us down. Okay, so this is a lot of information. But we can do it. Okay, the most important part is that we need to get our labels correct, and then we can draw in the graph. So, now let's think. Okay. Let's maybe do it in stages. Okay, so let's see what we can do. We know 5 times, let's do y is equal to 5 times the sine of 3x first. Okay, so we'll forget about the shifting left and right. Okay, so if it was just that, it would be difficult enough. The amplitude's easy. I'm going to say 5 and negative 5. That's not bad. Okay. Now, I have one cycle length, so I'm going to pick a length for my cycle. And in this case, what's the length of the cycle? It's 2 pi over 3. Okay. Now, we still need that middle part, okay, because we're still going to go half, half, and count it out. So what is this? Well, I just come up here and I do a little scratch work. I want to know what is 1/2 of pi over 3, of 2 pi over 3. Well, that's just 1 pi over 3. Now I want to know half of that again. So I'm wondering, what is 1/2 of pi over 3? And by multiplying fractions, that's just pi over 6. And now I can count this out. So if this distance is 1 pi over 6, this is 2 pi's over 6. Half of that is 3 pi's over 6, which is just pi over 2. And then this is 4 pi's over 6, which is 2 pi over 3. So we're good there. And we will be doing some shifting left, so let's just mark these out as well. And I just take the opposites of these. So this is negative 2 pi over 3. Half of that is negative pi over 3. Half of this is negative pi over 6. And half of this is negative pi over 2. Okay, so pi over 6 is, or 3 pi over 6 is pi over 2. Okay, so that would set us up, and then we would just go sine, top, middle, bottom. Okay, so let's just kind of dash in what one cycle of that might look like. Starts at 0, middle 0. Okay, so this would be 5 times the sine of 3x. Okay, now let's drop it to units. We can do that. Okay, so now if we do y is equal to 5 times the sine of 3x minus 2, well, everything's going to stay the same. It's just now this is negative 2. This is negative 2. This is negative 2. Okay. Now this comes down 2 units. So this is a 3. Right? Minus 2, minus 2. Now this is negative 5. It has to come down to minus 7. Okay, down here to minus 7. Okay. So it would look like this. Now don't get nervous, you guys. We're almost done. Okay, so as long as everything's clearly labeled, we can just work with it. Okay. Now we haven't taken into this into account. So we're going to do y is equal to 5 times the sine of 3 times x plus pi over 3 minus 2. Okay, so we're going to take this green graph and we have to shift it. We're going to go, because we're adding, we're going to the left, pi over 3 units. Okay, so this is 0, and I want to go to the left, pi over 3 units. So now, this point comes here. Pi over 6 comes over 1, 2, to here. This point comes over to 0, lays on top of that. And this point comes over 1, 2, to here, and so we're staying down here at negative 7. And then this point comes over pi over 3, which gets to here. So in the end, this is the graph of one cycle. Let's label these points to be clear. So this is negative pi over 3 at negative 2. This is negative pi over 6, comma 3. This is 0, comma negative 2. It's got to end up there too, so this is pi over 3, comma negative 2. And this one's pi over 6, comma, how much? Negative 7. Okay. And we can answer things about the range then of this new resulting function because it's been shifted. If it was just the original, we'd have an amplitude from negative 5 to 5, so the range would go from there. But as soon as we shifted it down in the green, the range starts at negative 7 and goes to 3, which the left translation kept. So the lowest value of y is negative 7, and the highest value is 3. Okay, let's do another example. Say you were given the graph and had to determine the equation. So let's say, for example, you had this graph. This was 10, half of that's 5, half of that's 2.5, so this would be 7.5, and this is 2, and this is 4. Okay, say you're given this graph, and you need to write an equation for this. Okay. So the first thing I'm going to do is determine which of the two graphs does this look like? Does this look like the sine graph, or does it look like the cosine graph? And I easily identify the sine graph here. Start, middle, and end, peak, and valley. Okay, so I know this is going to be something of the form y is equal to the sine of b times x minus c plus d. Okay, that's just the basic form of it. And let me see if I can start filling in what I know about these. Okay. Well, can we determine A, the amplitude? Well, in this case, here we have a midline that goes through y equals 2. So the distance between 2 and 4 is the amplitude. Okay, so our amplitude is 2. So that means A is 2. Okay. It is positively oriented, this graph, so it will be positive 2. Okay. Then the sine. Now, certainly these aren't in pi's, so the period, which B affects, we're going to have to do some work on. So let's just leave it like that right now. But I'm wondering, C would provide a left or right translation. And to me, this starts at 0 and ends at a specific place. So it doesn't provide a left or a right translation. So C in this case is going to be 0. And then we have to figure out if we're adding or subtracting. And this graph has certainly been shifted up 2 units, okay, because of this midline. So we're adding 2 when we're done. And let's just simplify this a little bit more. So this is y is equal to 2 times the sine of b times x minus 0, but that's just 0. Right? So we can put x minus 0 is just 0, so, or I'm sorry, x minus 0 is just x, so b times x is that. Okay. Alright, now we have to figure out how this period changed. So to do that, we have to come up here and figure out the length of the period. So from here to here is the period, and so we know that the period is equal to 10. It doesn't always have to have pi's involved with it. Okay. We also know that the period is equal to 2 pi over b. Okay. And we know that that equals 10. Okay. So now we can just solve this. 10 is equal to 2 pi over b, okay, over 1. So if we multiply both sides by b, okay, the b's will cancel. On this side we'll have 2 pi is equal to 10b. And remember, we're concerned about what b is. So we'll solve for that and divide by 10. So we get b is equal to 2 pi over 10, which is pi over 5. And so that's it. That's what we substitute back in. So the equation of this graph is y is equal to 2 times the sine of pi over 5x plus 2. Okay. So you have a couple of these in your homework to do. First, determine which shape it is. Figure out if it's been shifted up or down. Has it been moved left or right? What the amplitude is. What the period is. Remember, the period's 2 pi over b. Solve for b and substitute everything in. Okay, so that's going to take some work. This is going to take some practice, okay? We'll have to get there. Make sure you do this one a couple times so you can understand. It'll make things much easier for you. Okay? All right, let me know if you have any questions.